section 5.2, polynomials, linear factors, and zeros. And our objectives are to analyze the factored form of a polynomial and to write a polynomial function from its zeros. So we have already done factoring and finding x-intercepts on quadratics, right? We know how to factor quadratics, we know how to find the x-intercepts. We're going to be doing the same thing with the rest of the polynomials. The process is exactly the same. Okay? So, writing a polynomial in factored form. Can you guys see that, or does it need to be bigger? I'm going to make it a little bigger. Yeah. Okay, so what is the factored form of this polynomial? Notice it's not a quadratic this time. It is a, what kind of function? Cubic, and how would we classify it? Can we say cubic? Trinomial, lovely. All right, so to write it in factored form, we use our factoring techniques, and what is the first factoring technique we always look for? Greatest common factor. What can we pull out of all three of these terms? We can pull an x out. So if I pull an x out, I am left with x
squared.
Good, minus 2x minus 15. We're trying to get in factored form, so now I have a quadratic that I can factor. Right? Since we already know how to do this, we multiply the first term times the constant, we get negative 15. Factors of negative 15 that adds to negative 2. 5 and 3.
It should be 3 and negative 5.
Good. So 5 should be negative, and 3 should be positive. Now, as we continue, just leave that x out in front. Hey, you with me? Okay. Leave that x out in front as you continue to factor. So I'll put a big bracket to make it easier. And the coefficient on x squared is 1. So these are my factors, correct? So I'll have what? X, help me, that's minus 5 times x plus 3. So in the end, we have x times x minus 5 times x plus 3. That's it. If you are simply asked to write the factored form, that is it.
Otherwise, you just do the zero product.
Next, when we solve, we will do the zero product, exactly. That is where we are going. All right, questions on that? So generally, the only extra thing you need is to most likely factor out a greatest common factor first, and then use your quadratic factors.
So do all existing things like factoring and quadratic formula, so everything works for this.
Quadratic formula only works for solving for the zeros of that thing.
So we're gonna you have to get to that point first.
Yes. So at this point, we could have, if we were solving it, we could say x equals 0, and x squared minus 2x minus 15 equals 0. We could solve that with quadratic formula if we wanted. But they wanted factored form, so there is our factored form. All right.
We did that one, but I didn't do
that. All right. So, just things that you need to be aware of. Let's read through this. The following are equivalent statements about a real number b and a polynomial. So we have some polynomial p of x that could be 3x to the 5th plus 4x cubed and so on down to some constant. These are just terms that you need to be familiar with. So, x minus b is called a linear factor of the polynomial p of x. Why is it a linear factor? Because it's x minus b to the first, which makes it linear. And if x minus b is a linear factor, just like we had when we did quadratic, b ends up being a 0. What are the other words that mean the same thing as a 0?
What did you tell us?
When we solve for quadratics, we're solving for what? There's what. So, b is also known as an x-intercept. There you go. So the three terms, 0, root, and x-intercept all mean the same thing. So if I have some polynomial that looks like that, and I ask you to find the zeros, or the roots, or the x-intercepts, I'm asking you to find that point, and that point. All right? Okay. Can I move on? Okay, all right. I'm not moving on. I might pause.
Color group is
Okay, so moving on to the next example. Find the zeros of a polynomial function. Shush. So here they've given you a polynomial in factored form already. Y equals x plus 2 times x minus 1 times x minus 3. And they're asking us to find the zeros. So now we use that zero product property. And we take each factor and set them equal to 0 and solve. So here are our three roots. And now it says to graph the function. Yes.
You said that's the factor form, like up at the top,
Yes.
right? How do you find the three terms of factors?
So you'd have to FOIL these two. It could be,
Spell it the other way to get three terms?
you'd have to have some other method.
Okay.
Because when we factored out the greatest common factor, that's easy enough to see. But there are other methods for factoring larger columns. Which we're not talking about quite yet. More mathy ones. Yeah. All right. So this graph the function. Well, this function is what kind of function? Cubic, quadratic, quartic, what is it? It is cubic, because when I multiply all these out, I'm at the biggest power of x will be x to the third. Okay. And is the coefficient in front of x cubed positive or negative?
Positive.
Indeed. So I know that this one's going to look something like that. It's going to rise to the right. And I know where the zeros are. So I could do a sketch of this graph. It won't be exactly accurate, but it'll be close. I know I have a root at negative 2. I'm going to put a point there. I have a root at 1. I'm going to put a point there. And I have a root at 3. Point there. And I know this one's got to rise to the right because x times x times x is positive x cubed. So that means I could approximate what this graph looks like by coming up through here. I know it's got to turn around and come back down through that one. And I know it's got to turn around and come back through that one. So tell me what is not accurate about my graph. My turning points. I don't know where they are. I don't know how high they are or how low they are. But this is a nice, quick sketch of what this function will look like. And then you should be able to graph it on your calculator to find where those turning points are. Okay? Any questions on that? Thank you. All right, let's move on.
There's any questions like that, and it's just an absolute sentence.
Sometimes we do that in calculus quite a bit, where you just want to get an idea of what it's going to look like. So it's a good skill. All right. So just taking note of the theorems that they are providing in this section. The factor theorem, you don't need to write this down. Let's just read through it. The expression x minus a is a factor of a polynomial if and only if the value of a is a 0. Well, that's what we said before. If x minus a is a factor, then we set it equal to 0, and x equals a is a root. You do not need to write this. This is just reviewing some things. Quiet, please. Back. Okay. All right. How many multiple zeros affect, how do multiple zeros affect the graph? So this is very fun to figure out. We have factors of a polynomial. Let's read through this first and then we'll make it a little easier to understand. If a is a zero of multiplicity n in the polynomial function p of x, then the behavior of the graph at the x-intercept a will be close to linear at n equals 1, close to quadratic at n equals 2, and close to cubic at n equals 3, and so on. So let's figure out what they're trying to tell us. Take good notes on this one. So let's say I have a function f of x equals, in factor form, x minus 1 to the first times x plus 2 to the second times x minus 3 to the third. So these are factors, and if I wrote them all out, x minus 1 times x plus 2 times x plus 2 times x minus 3 times x minus 3 times x minus 3. Okay, so what is the degree of this polynomial?
Oh, that one?
It is to this day. Okay? All right. Now, we can figure out some more things about what this function looks like by looking at the powers on its factors. So if you have a factor that is raised to the first, that means at x minus 1 equals 0, so x equals 1. At 1, the function will come straight through that 0, just like a line, because it's like an x to the first is a linear graph, so it's either going to look like this or like this, but it's going to go straight through. All right? And then at x plus 2 equals 0, x equals negative 2, well, what does a function to the second look like? A parabola. So at x equals negative 2, at the x-axis, the function is going to look like a parabola. It's going to bounce off. Oh, I went too soon. Try that again. So at negative 2, it's going to come down and it's going to bounce off like a parabola. So it can either look like that, or it could have been from below and look like that. So if your factor is squared, then it's going to look like a parabola at the x-axis. All right? Well, what does a function cubed look like? It looks like that S-curve. Well, that's what it will do through the x-axis if your factor is cubed. So for this one, x minus 3 equals 0. We get x equals 3. And the options would be, it'll come up like that, true, x equals 3, or if it's coming downward, it'll come down like that. So the behavior of the x-axis is just like what the functions do when they are raised to that power. I think it's really neat.
Oh, yeah.
Maybe someday you will agree. It's so cool. Okay, sorry. All right. So now, what are the zeros of this function, and what are their multiplicities, and how does the graph behave at each of the zeros? So what we need to do is put it in factor form. When it asks for the multiplicities, they're talking about what power they're raised to. Okay? So let's go ahead and look at this one. We have x to the fourth minus 2x cubed minus 8x squared. All right, so we want to factor this. What can I pull out in front? X squared can come out in front, leaving me with x squared, louder, minus 2x, minus 8. All right, so I have an x squared out in front. Now we want to factor this guy. Factors of negative 8 that adds negative 2. 4 and 2, which one's negative? The 4. So now I've got x squared times x minus 4 times x plus 2. Okay? And then what are my zeros? X equals 4. Negative 2, there's one what? 0. You have to set that x squared equal to 0 as well. Okay, so those are my zeros. And the multiplicities. So at x equals 4, what's the multiplicity on that one? 1. Negative 2? 1. And 0 is 2. All right? And tell me what happens at x equals 4. Does it go straight through? Does it bounce off? Or does it S through? Straight through. That's a very long word for me to write that way. All right, and what about negative 2? Straight through. And what happens at 0? Bounce.
That's all you can do?
Yep. So when it talks about what it does on the graph, straight through, bounces off, or S's through. Okay? So there's our work for this problem. Okay, any questions on that? Factor it, look at the multiplicities, and then decide what it does at the x-axis. Tempting.
And the x squared is absolutely to 0.
Yes. So if we, exactly, because it's the second degree, that's really x minus 0 squared, to make it look like the others. Okay? All right, any other questions on that? Okay. I think we're done. It was not that bad. Come on. All right. So homework for tonight.
Yay.
I do not have the assignment sheet updated, so let me look at it and pick my numbers.
How about we do 0 to 0?
I will be checking this homework, so have it ready. Okay. So we are at page 293. And we will do 7 through 37 odd. Page 293, 7 through 37. Nope. 7 through 37 odd. All right, get your books out.